All right, we're going to do all things synthetic, including synthetic substitution, synthetic division. All right, and we're also going to learn how to divide not just numbers again, but polynomials. So let's start with this synthetic substitution. And just like any other substitution, we could solve that. You already know how to do substitution in here. We can plug in p of -2 equals, and you can go down and replace all those x values with a -2, right? I can just plug all those in, plus 2 times -2 plus 1. If I do the math, that's -32 plus 12 minus 4 plus 1. And when you add all of those, I've previously worked this out. I'm not really doing it in my head here, but it's -23. So when I plug in a -2, you can get -23. Well, there's another way to do that, doing something called synthetic substitution. Synthetic substitution is a way to kind of just cut this down to the bare bones. So we're going to plug in a -2. We make a little box, put the -2 over here. And then all we do is we take the coefficients. Now, you got to be real careful because this is a cube, the square root of first power, and no x, so it goes down, the power goes down. If it doesn't, you have to fill in the, so for instance, if there's no x squared, you have to plug in a 0x squared. But in this case, I write my coefficients 4, 3, 2, 1. And the very first time, all you do is drop down the 4. And then you repeat this. And you're going to get really used to this because we're going to use this when we do synthetic division as well. You multiply, and then you add straight down. So that gives me -5. And then I come back and I multiply this again. -2 times -5 is 10. I add straight down and get a 12. Then I multiply again. It gives me -24. And I add straight down and get -23. Oops, -23. And if you look at it, that represents my answer. So what does your final number represent? Well, it represents p of x, I should say p of x, when x equals -2. Or I could say the fact that p of -2 is equal to -23. That's what it represents. All right, so that's synthetic substitution. And I put that on here. It's kind of just a different way of using this process that we're going to use a lot when we do division. And we'll get to that very soon. My goal is to get through like this page and one other page for this video. All right, so if you guys remember how to do long division. So I have 277. I'm going to divide that by 12. It's basically a process of say, how many times does 12 go into 2? Well, not at all. It goes into 27 twice, and then you go 2 times 27. 12 is 24. You subtract, you get 3. You drop down your 7. Well, how many times does 12 go into 37? Well, 12 goes into 37 3 times, 36. And we get this one remainder, all right? I got to write remainder of 1, right, R1. But what it really is when you divide it, you get the fact that it goes in 23 times plus 1/12, because if this was a 2, that would be 2/12. If it was a 12, I'd have no remainder, and it would go back in there. So this is your fractional remainder, and to represent it as a fraction, do it over here. If we were to write that down here, right, we could say, hey, here's what this is. This is, and we're going to show that this is true, right? We could say 277 over 12 is equal to 23 and plus 1/12. We can prove that pretty easily, right? We could take that, and I'm going to write what we'd have to do. 277 over 12 equals 23 plus 1/12. We could prove that by multiplying both sides by 12, right? Moving the remainder. Well, if I multiply this side by 12, that cancels out, and we'll just say, hey, it's equivalent to 277, all right? And 12 times 23 is 276, and 12 times, that should be a 1/12, is 1, and sure enough, those are the same. I've checked it out, right? This means, can this be used as a means to check your work? Yes. So after you're done dividing, if you multiply everything by what you divided, you should get your original answer. So there's one done. Now, I'm going to show you, all right, long division. Now, long division offers you more options, and it's done the very similar way that we've done other things in the past. But I'm going to show you a more efficient way for solving problems like these two anyway, later on, called synthetic division. Well, we do the same thing. When I divided on that last page, I put my divisor, what I was dividing by, on the outside. So here I go. I'm going to say x plus 1. And then what I'm dividing into, right, I put in here. So I got 4x cubed. I make sure that my next one says x squared. I make sure that my next one has just an x to the first power and a 5. I'm going to do all three of these, so we're going to go through, and I'm going to tell you my trick. Your goal is to always make this first one cancel out. So my question is, what do I multiply this by to turn it into this? Or I'll multiply x by to turn it into 4x cubed. Well, I obviously need 2 more x's, so x squared goes there. And that's a 1, so 4 times 1, and that works. Like 4 times 4x squared times 4, or times x. 4x squared times x is 4x cubed. And then you got to multiply by this as well. 4x times 1 is 4x squared. And you're going to take this entire amount, just like when you do division, you subtract. Well, this gets kind of confusing for some people, but let's go through. 4x cubed minus 4x cubed is 0. 2x squared minus 4x squared is negative 2x squared. So be really careful with your signs here. And you drop one down. Basically, you're going to drop down as many as you have terms over here. So if there's 2 terms, I need to drop it down until I have 2 terms here. And now I ask myself the same question, but instead of using the 4x cubed, I use that negative 2x squared. What do I multiply x by to turn it into negative 2x squared? Well, I need a negative 2, and I need another x. And then I multiply. Negative 2x times x is negative 2x squared. Negative 2x times 1 is negative 2x. All right? And I take this entire thing and subtract it. It's probably easier to add the opposite. These guys will always cancel, and these guys make 5x. And for the last time, I drop down my extra number, 5. I say, what do I multiply this by? What do I do that? What do I multiply this by to turn it into 5x? Well, the answer is 5. 5 times x is 5x. 5 times 1 is 5. Wow, did that work out? It sure did work out. All right, I get a remainder of 0, which is kind of nice. So if I look on here, what I've got is I have an answer that looks like this. And I can say that my answer is, and how does it tell us to write it? Divisor, quotient, plus remainder, and then carry out the multiplication. So there's a trick to it that we can check things out. But our answer for right now is going to be 4x squared minus 2x plus 5. All right, I'm going to circle that answer. They're saying to check answers, but to keep we'll have to check one in class, but to keep it kind of a shorter video, I'm not going to check this answer. We're already at 8 minutes, and I don't want to go too long. We've got 2 more of these problems to do. So I'm going to do the same thing. All right, this one's got a tricky spot. I'm going to mark that tricky spot. It's right in here. There's no x squared. So we're going to have to fill in the blank. So I go over here and I say x plus 2, and then I write everything down. I got x to the 4th minus 3x cubed, and I need an x squared in, so I'm going to say plus 0x squared, and I'm going to fill everything back in, negative 5x minus 6. So I want to make sure all my exponents are represented from 4 down to nothing, like 4, 3, 2, 1, 0. I just filled in the spot between these two. Same question. I'm going to go a little quicker, right? Where I multiply x by to turn it into this first term, and that's x cubed. X cubed times x is x to the 4th. X cubed times 2 is positive 2x cubed. I'm going to remind myself that I'm subtracting all of this from this, the entire binomial. These guys cancel. And negative 3x cubed minus 2x cubed is negative 5x cubed. I drop down my next term of 0x squared plus 0x squared. And I ask myself the same question. What do I multiply this by, this first term, to make that term? It looks like negative 5x squared. So here we go. Negative 5x squared times x is negative 5x cubed. Negative 5x squared times 2 is negative 10x squared. And then, I should have drawn that line there, but I subtract all of that. These guys cancel. Negative 5x cubed minus negative 5x cubed cancels out, and this turns into positive 10x squared. And I drop down my next term, negative 5x. Right? Just drop it straight down. Same question. What is this? What makes this turn into this? That'd be a positive 10x. 10x times x is 10x squared. 10x times 2 is positive 20x. I remind myself to subtract all of that, which gives me negative 25x here, and those cancel out. I drop down my last number, right, a negative 6. To turn this into this, I put a negative 25 there. Negative 25 times x is negative 25x. Negative 25 times negative 2 is negative 50. I got to remind myself that I'm subtracting all of that. These guys cancel. Negative 6 minus negative 50 is the same as a plus 50, right? Which gives me 44. So, my remainder is 44 over my divisor, x plus 2. Right? So, my answer would be x cubed minus 5x squared plus 10x minus 25 plus 44 over x plus 2. There it is. Alright, we got one more, and we're at 11 minutes. So we got time to do this. So, and this one looks pretty short, actually, so let's see what we can do. It's kind of cumbersome. We get some stuff to fill in that we're dividing by a longer number here, but that's alright. So here we go. We got 15. I should give myself more room. Let's kind of cancel this. I left my pencil in my room, so I'm stuck with this pen. And I don't have that x squared, so I say 0x squared. I got it just in 8x, so I put that in there, minus 12. It's going to be a pretty short problem, actually. And out here I have 3x squared plus 6x plus 1. What do I multiply 3x squared by to turn into 15x cubed? That's just 5x. You just multiply through over here. So 5x times 3x squared is 15x cubed. 5x times 6x is positive 30x squared. X squareds are lined up. 5x times 1 is 5x, and we're making sure that like terms are lined up right. And you got to remember that you're subtracting this. So 0x squared minus 30 is negative 30x squared. 8 minus 5, right, is positive 3x. Then I drop down my next term, my last term. I'm almost done. What do I multiply 3x squared by to turn into a negative 30? That's just negative 10, right? Negative 10 times that is this, negative 30x squared. Negative 10 times 6 is negative 60x. Negative 10 times 1 is negative 10. And I have to remind myself that I'm subtracting those, which is kind of like adding the opposite. Cancel. This turns into 63x. This turns into... Oh, I don't think I did the opposite of that, did I? I didn't. I should have put a plus sign. I stopped there. And that turns into negative 2. So I'm going to write my answer over here. My actual answer is it goes in 5x minus 10 times with a remainder of 63x minus 2 over my divisor, which is 3x squared plus 6x plus 1. I should try to reduce this, but nothing factors out over here. And I can't think of anything that multiplies to 3 and adds it to 6. So I'm going to circle my answer. All right. So that is long division, which we will practice in class tomorrow. I want to point out that I left D here for you. Realize you're going to have to fill in a gap here. There's a gap here. You're going to have to fill in a gap there. That's going to be x squared and 0x plus 16. So try D, and you're going to compare that in class tomorrow. Sorry, I don't have a highlighter. If you have a highlighter, do it there, please. And for right now, that's it.